Okay, Paul here. Today on the bench I have this antique fan motor. It's a General Electric, and the number is 30, looks like 33, 77, 38. It might be 38, 77, 38. Anyway, and it's rated 110, 60 cycles, dated April 26, 92, I don't know, March 14th, 93, August 13th, 95. That just don't make no sense. Well, maybe. According to that, it's pretty old. Anyway, the customer sent it in because it stopped working. And I wanted to document what it looked like. I checked the, here, let me put some connectors on here and you can see what we got. I'm just hooking up some clips on my phone here. If we go to line cord, you see we have 53, 55 megs. It's climbing up. It's probably got a capacitor. I haven't pulled the bottom out yet. Yeah, that looks like a capacitor. And it went all the way up. And that's with the switch on what should be off. I move the switch to the next speed. Climbing up again. But it's in the meg ohms. So it looks like the only thing happening here is, it looks like a capacitor charging. It's just so weird. Yeah, that's what it is. Okay, and in off, well, okay, it went to nothing. So I took the bottom off. I didn't like these wires. I started separating them a little bit here. You can see some of the insulation off of them is gone. And I'm hoping that they didn't short out inside. It looks like somebody accidentally scraped them here when they were doing work on it. They put in a new line cord with an acorn plug and ran it up new head wire. So the next thing for me to do, obviously new screws. It looks like they made this plate. That doesn't look original to me, but it could be. It's possible that they made this plate. It doesn't look age specific. It could be, but it's in really good shape. It was cleaned up. If it is old, I don't think so. I think it's, oh, maybe that's ceramic and not aluminum. Yeah. Okay, let me go ahead and pull the base out and we'll take a look further. But right now it's not looking good. Well, before we do that, let's check across this speed coil from here. See if we can get anything. If we set that there and here, these clips are not liking that big old bolt. Okay, we got nothing there. All right, so let's go across the coil. Well, that is part of the coil, so we got nothing there. We got nothing here. And it looks like these two wires are going to the same place, and maybe somebody stripped them to try to check across here, make sure that they were actually reading across the coil and not that there was lack of separating them, but still nothing. So it seems like there's an issue for sure. Let's go ahead and pull it out and we'll take a look at it. Okay, here's the unit out of its case. Let me get a little more light on it for you guys. Okay. There's the speed coil and the contact mechanism. Let's check across the line cord and stop from there. And I'm going to put my meter on continuity because you're not going to see it, but you'll be able to hear it. See? Okay, so let's check the line cord. I'm sure it's fine, but we want to rule everything out as we go. Okay, so that side's fine. Let's check this side. Okay, so the line cord's fine, so we're good up to there. This is the wiper here. This wiper connects to this outlet. Goes through the speed coil. This would be high, which would be directly connecting this to this. Let me get my light in a better place. Directly connecting this line cord wire directly to the motor. So this side's connected to the motor. This side is connected, excuse me, directly to the motor, and that would be high speed. Then this would be medium speed, and this would be low speed. So as you go down, you're going through more of the speed coil. And right now, we're not getting anything across the speed coil. And, and if I go across the motor, no continuity. So there's a possibility that one of the head wires is loose on the motor, but the plot thickens when we consider that we have no continuity across. Oh, we do now. Okay, so that speed coil, oh, that's strange. I wasn't getting no reading earlier. It's working. There's nothing there. So the low is not working. The medium, is that touching it? No. Let me put this in the off position. Okay, that's off. So it goes to low, medium, high on this particular fan model. So from medium to high, we have connectivity. From low to high, we don't. And why not? That coil might be bad on the low speed. It may only have two speeds at this point, medium and high. Oh, wait. I heard something. Not getting a reading for that now. I did hear something. What was that we were hearing? Let me take that one off. I'm doing this stuff with what? Excuse me. It's fun doing this with one hand. Okay, so we do have a connection there, but none there. So the wire is good going into the speed coil, but it's not good coming out. Hold on. Something is weird here. Let's separate those two. Connect to that one. Okay, so this has two coils. Yep, this has two coils. And one is going to be lower resistance than the other. And we need to figure out how that should play out. What I'm thinking is they got it wired wrong here. It should probably be something like these two wires would go together. And so from here to here, you would be on low, you'd go across both coils in series. From here, you'd only go across the last coil, and then there would be high. But what we need to know is which two go together, and that's, let me think. Well, it really isn't going to matter, because when it's on low, it goes through both coils in series. When it's on medium, it would matter that on the medium speed if these two coils weren't the same resistance. If there was a higher resistance in this coil than in this coil, then on medium you would have an option. You could either have medium at a slower speed than if you switched the coils, and then the medium would be at a little bit higher speed if the resistances are different. Does that make sense? I think I can show you that. And I still think there's probably a problem with the head wire in the motor. It doesn't look like anything got hot here, so I'm not expecting to find a problem other than a broken head wire up on the top side, but we need to verify that. We haven't got to that point. Right now I just want to get these working. So I'm going to turn the meter back to normal ohms, and we're going to check the resistance across both these coils. So this one has a resistance of 15 point, well, let's say 15 ohms. It's dropping, but that's just inductance. Let's see where it settles at. 14 point, it's going to trick me. 14 ohms. Okay, now let's see what this one has. This one has the same thing, 14 ohms, so it doesn't matter how we connect them. What I'm going to do is fix this. I'm going to put this over there where it belongs and put this one over here, and it'll have low, medium, and high instead of just low, off, off, medium, and high is what it's got now. Or off, off, low, and high is what it has. So we'll try setting that up. Next thing is I'll put this back in since we know everything's fine up to here, and we'll take the motor apart and take a look at the head wires. Bear with me while I hook this up. Okay, I got them connected back up, and I zeroed out my meter so we would have better readings. So we got 4.4 ohms across from low. This is due to low speed from here with the wiper here through both coils over to here. We got 4.4 ohms. With the wiper here, we're only going through one of the coils, and that's 2 ohms. So that makes sense, right? Half of 4 is 2. So, and both coils measure the same resistance. So that fixed that problem. Now we got to check the head wire. Let me set up for that. We're going to pull the motor apart. And I found out a couple issues. So the head wire is fine. That's next. There's a problem here with these wires. They could definitely be cleaned up. Looks like somebody put some this stuff on here, which is liquid electrical tape, but the wires are deteriorating even further down toward the coil. And you remember we have 0 ohms across. I'm actually across the head wire. I went ahead and pulled it out, and I'm just connected to, if I can find it, I'm just connected directly across the head wire here. So it goes through half the coil, well, part of the coil, then it goes through here, goes to the armature to engage the armature with brushes, and then it comes back here. And if you see, I turn this, let's see. There you go. You hear that? Yeah. So the problem is in the brush assembly here, where it touches the armature. It has to make contact across the armature to create the magnetic field on the armature. But the problem is not the head wires, the problem is this section here. So if I take this back out, of course one of the washers stayed in there, but that's no big deal. So we'll set that guy there, out of the way. Let me get that washer out of there. I'm gonna find a tool to do it. Two of the washers stayed in there. Okay, they're just spacers. There they go, back on there. Okay, get them back in place. Here's the issue. This unit has been busted. See how it's broken here, broken 3 places. Two pieces broke off. And over here, the piece broke off and it's missing. And you see how rough this is here, if the camera will focus. Gotta get it to focus. Well, that's the best I'm going to get that, I guess. If you notice the screw, this screw here looks, well, one, it looks cockeyed, but two, it doesn't come to the edge of the hole here on this side, on the clockwise side. Look at this one, same thing. It does not make contact to the metal on the clockwise side, which it would if it was not broken. It would be countersunk. Both of them are countersunk, so the screws would be perfectly perpendicular to the bracket and into the screw holes. But this one even looks like it's not even straight in the screw hole. So that even made it even worse. It's leaning this way and it's still not touching. So that means that this may be off center. And that might have been intentional to try to move this closer to the center. I don't know. I don't know what they were thinking or what they were doing when they glued this together. Really, this piece needs to be replaced. Finding it would be just about impossible. You'd have to destroy another fan of this age or find one that's a parts fan. Or it has to be created in a machine shop. Taken off, taken to a machine shop, have them mic it, and make another one. Clean all this goo and glunk off, hope that that screw hole in the cast metal is not messed up. I'm sure it's just a screw. Get new screws and reattach it. That would be the only way to make sure that that continually makes contact. I mean, this is a probably 1890s fan is what I'm getting. It's dated 95, it's sure not 1995. So 1895 fan, it's been around a while, and this whole design is totally different than modern day fans. The sides of the armature is definitely bigger than modern day fans, so finding a replacement armature that would work would be difficult. But I don't think the armature is totally bad. I mean, I know that this is worn down, but this is the culprit, and this is in bad shape. This is totally deteriorating. And inside too, you see cracks in there, surface cracks in there. They're not cracked through, but that's stress from heat and things. And you see on this side, let me shine it down in that wall. See, there's deformities. You know, it's probably made in a, well, oh, it's definitely cracked through there. That's not good. I didn't even see that. You see where it's broken right through? There's no way that this is going to last for any major length of time. It's going to have another one of these contact plates designed. So there you have it, but I'm going to put it together. Then I'll show the owner. Then it'll be up to the owner if they want me to pull this out and send it to, send it to them separately so they could take it to a machine shop. That's a possibility. They can maybe get one machined. I don't know. I don't know if the fan's worth it. But if they want to do it, if it's got sentimental value, whatever, they could do that. And then they can have it reinstalled. So however that wants to play out, that's up to the customer. And it may become a shelf queen. I mean, that may be all they can do with it is till they find a similar fan that they can get for parts. Maybe they can find a parts fan where it's got low mileage on it and this plate's still in good shape and they can repair it or even replace the entire back cover with the new plate. Of course, you know, you have to solder it to the existing wires. So let me see what I can find out and I'll assemble it. Thanks for watching.